right, number 3, let's check for a GCF. They do not all have x's, so we can't factor out an x. They do all have numbers, but 2 is prime, so really the only thing I could factor out is a 2, and where you have a odd number here, that's not going to work. So this is going to be star method with divide and slide. So we're still going to put the 9 at the top for our addition, but then we're going to multiply the 2 and the 10 at the bottom to be the 20. Don't forget to do that step. That's our multiplication. So let's look at all the things that multiply to be 20 and see which one we can get a 9 from. And it is going to be the 4 and the 5. So x plus 4, x plus 5, but we do not stop there because of the 2. So we multiplied by 2. Now to fix it, we divide by 2. So 4 divided by 2 is a nice whole number. 5 divided by 2 is not. So we slide that denominator over to make that 2x plus 5 equals 0. Went kind of fast because we've already went over factoring. So if you need to rewind and watch that part again, that's fine. So multiply, find your factors, divide, slide if necessary. So now that it's in its complete factored form, now I can look for my intercept. So this first parenthesis is going to be the easier of the two parentheses. So how do we make a positive 2 into 0? Well, we got to have a negative 2. All right, so there's your first one. The second parenthesis is going to be a little bit harder because if the 2 wasn't there, we could just say negative 5. But that 2 is going to make it a little bit trickier. So there is a shortcut, but I'm not going to tell you right away. I'm going to show you the long way, and then I'm going to kind of point you in the right direction for the shortcut. So really, if we want it to equal 0, well, that's a solvable equation set equal to 0. We want that parenthesis to equal 0, right? So let's create a two-step equation where that parenthesis equals 0, and let's solve it. So you'd subtract 5 from both sides. So there's that negative 5 I told you about earlier. If the 2 wasn't there, we would need the negative 5. So you can already kind of see it start to show up. But then we have to undo the multiplying by 2, right? So we would divide by 2. So it's going to be negative 5 halves. Now I want you to think about this for just a second. Look back at our work. Do you see a 5 over 2 anywhere else? Well, right up here, right before we slid that denominator, right? See the connection there? So really, we divided by 2, we slid it, but then to get the 0, we had to just go back and divide it by 2 again. So there's you a little bit of a shortcut. Some people recognize that and remember that very easily. If you do, that's great. If not, you can always solve the two-step equation. When in doubt, solve the two-step equation. I'm going to say it one more time. When in doubt, solve the two-step equation. It's okay. It's going to be fine. Now, when we go to Desmos, it will not pop up as 5 over 2. So let's go ahead and convert that to a decimal because Desmos will only give us the decimal equivalents for the points. So Desmos is going to give us negative 2.5, which is the same exact thing. But let's just go back and see, just like last time. So y equals 2x squared plus 9x plus 10. Okay, and this one I'm going to have to zoom in a little bit, which is fine. There's your negative 2.50, which is the negative 5 halves. And there is your negative 20. Great way to check our work.